Hello everyone and welcome to day 2. Today we're going to be learning about evaluating logs, graphing logs, and simplifying logs. It's going to be a bit of a condensed lesson, so please pause when you need to, repeat when you need to. I will be asking you to do a lot and going through this fast, so please pause when you need to. So in example 1 we have the function y equals 2 to the x, and it's been graphed for you in the black right here. And it asks if it's 1 to 1. And 1 to 1 states that every x is mapped to only one y, which makes it a function, and that every y is mapped to only one x, also meaning that it passes the horizontal and vertical line test, and that is the case here. So yes, that is a 1 to 1 function. And then it says, based on your answer from part A, what must be true about the inverse of this function, and it is also 1 to 1 and a function. Remember, the inverse doesn't always have to be a function. In this case, it is a function. It does pass the function does pass a horizontal line test, implying that the inverse is also a function. The next thing I need you guys to do is create a table for the inverse. Now, the inverse, let's not forget, the inverse is also created by switching the x and y coordinates and reflecting over the xy axis. So that's what you're going to do right now. And so we have the points, and you'll also notice that the graph is reflected over the line y equals x, which we talked about in previous units. So what would the first step be to find an equation for this inverse algebraically, solving it algebraically? And the first step would be to switch x and y. And so instead of having y equals 2 to the x, we now have x equals 2 to the y. And it wants us to stop, because now we're going to look at what a logarithm actually is. The function, listen carefully, this is how we correctly say logs. Y equals log base b of x is the name we give to the inverse of y equals b to the x. So for example, y equals log base 2 of x is the inverse of y equals 2 to the x. And here's what people sometimes mess up, and what we need to understand. If y equals log base b of x, the logarithm gives you the exponent. Okay? So what the logarithm is equal to gives you the exponent of the other function. So notice here that the log is equal to y. Y is in the exponent. The base here, the base is going to be the base of the equivalent, logarithm gives you the exponent of an equivalent exponential form here. So the logarithm gives you the exponent in equivalent exponential form. I know you can't really read that, but you can write it from what I said. And then the x here is the answer to the last part. So the logarithm gives you the exponent in the equivalent exponential form. And so therefore, I'm going to skip the inverse part right now, and I just want you to look at this part. Convert the following from exponential to logarithmic. Notice that this is the exponent. So we have log base 10 of y equals x, because we know that the logarithm has to equal the exponent. We know the base is 10 and the other variable is y. Exponent here, 4 equals log base 2 of 16. The base is 2, 16 is the part that's left, is the answer. Negative 1 equals log base 6 of 1/6. And sometimes we put parentheses if you think you could get confused with that. Okay. Let's go to the next part. This says convert the following logarithm into exponential form. Our base 6, our exponent y, equals x. Our base 4, our exponent, it's what the logarithm equals, 5/2 equals 32. So knowing this, let's go back up and let's look at find the inverse. The first thing that we want to do is switch x and y. 2, solve for y. And then 3, we have to make sure that we replace f inverse of x with y. Okay, or 4y, sorry, 4y. So we have x equals 5 to the y. We now want to convert it into the equivalent logarithm form, because that's the only way we know how to get an exponent from is to log it. So we have y equals the base log base 5 of x. Y is now by itself. We solve for y, and we now write it in the f inverse form. F inverse of x equals log base 5 of x. Okay? Let's look here. X equals log base 4 of y. Ooh, we switched it now. We want to solve for y. Well, the only way we can solve for y is to put it into exponential form. So we know 4 is our base, our exponent is x equals y. Oh, look at that. It's solved for y. And therefore, we now write f inverse of x equals 4 to the x. So those are our two answers right there. So logarithms are the inverse of exponential functions. Exponential functions are the inverse of logarithms. If you're trying to solve for an exponent in an exponential function, you're going to use logs. That's key to know. If you're going to solve for an exponent in an exponential function, you are going to use logarithms. Okay? So, I'm going to have you guys, I'm going to set this up and then have you guys try this. Here, let's look at this. We're trying to evaluate it. What we're trying to say is, what does this equal, right? What does it equal? So, again, logarithms gives you the exponent in exponential form. So, base 3 to the x equals 27. 3 to what power gives you 27? Well, that implies that x has to equal 3. You know that 3 to the third is 27. You just have to, in these parts B, C, and D, you just have to know that 3 to the third is 27. You can use your calculator to help you. This one, again, if I put a question mark there, 27 to what power equals 1/9? Well, this is a little more difficult because we have a fraction here and we have 27. So the first thing we want to do is put common bases. We did this in the exponential unit. Remember that we can rewrite 27, we actually just did it right there, as 3 to the third. And we can write 1/9, okay, as 1 over 3 squared, or 3 to the negative second. And remember that this is our x. Remember this being raised to it. So we really have 3 to the third and then raised to the x. That's what we have here. This is, we put an x here. Well, we know that when we have the same bases, we can set the exponents equal to each other. You know that an exponent to an exponent is multiplying. So you have 3x equals negative 2, and x equals negative 2 over 3. If we look here, and we can set that equal to x, I'll change colors so we don't get confused. 100 raised to the x equals 0.1 can also be written as 1/10. So what I would like you guys to do right now is pause it, see if you can do C and D, and I'll come back with the answers. So pause it, see what you got, come back with questions. In class, notice that f of 64, this is really your x value, so I plugged in 64 for the x value to get the answer. Pause it, come back to class with questions. Graphing, I'm not going to spend time on this, I'll just write it in. Notice that if you have a calculator, use it right now. Use this and then try to graph it. Make a table and graph it. I will come back with the correct answer. And that we're not going to spend time on it though. Here's what the graph should have looked like. Again, notice that y is approximated and therefore your range is going to be approximated. Pause it, make sure it's right, and we'll move on. Before I go into explanations, you need to pause this and read the exponent and logarithm laws. You need to understand them, and then we'll get into the example. So pause it and read it. Go over each of these exercises until the end of the video. And so let's start. I'm going to have you do a few on your own when we get a chance. Notice that this is multiplication. We know that multiplication implies addition. 9 times x, and therefore we're going to rewrite it as log base 3 of 9 plus log base 3 of x. You know from before that this is 3 to what power equals 9 plus log base 3 of x. Well, we know 3 squared equals 9, so this is 2 plus log base 3 of x. Whenever you have two numbers, you have to think 3 to what power will give me 9. Quotient here, division, implies that you are going to subtract. And so what we're going to write down here is log base, there's no base, so log of x squared minus log of 1,000. Now, one of the things that we talked about last class, and what we need to talk about again, is that when there is no base, you are implying that it is base 10. Okay, you are implying that this is base 10. So when there is no base, it's implying that it's base 10. So therefore, the power rule states this 2 comes out in front. 2 log base 10, but we don't need to write it, of x. This, we have two numbers, so we're thinking 10 to what power, remember that logs give you the exponent, equals 1,000. Well, that's 3. So we have 2 log x minus 3. And I'm going fast, pause it, and think if you need to. We have a log of 12, and we are looking for in terms of the numbers 3 and 2. How can you get 12 in terms of 3 and 2? Well, we know it's going to be 2 times 2 times 3. Because it's really 4 times 3, and how do we break up 4 since we don't have 4 here? 2 times 2. Which this then implies that we have log base 2 plus log base 2 plus log base 3. And we know what log base 2 is. We know that log base 2 is b. We also know that's b. We know this is a. And therefore we know that log base 12, that's what the imply symbols mean, is 2b plus a. And when you look at that, you see it's a plus 2b. I would like you guys to try 4 and 5 right now, so pause it. Try 4 and 5. And then we'll go look at 6. So for 6, we have a composition. This is f of g of x. And so when we have f of g of x, we're taking what g of x is and plugging it in for x in f. And so we know that g of x is 100x cubed, and we're going to plug it in for x. That's called a composition. So we have log of 100x cubed. Again, this is multiplication, so we're going to write log of 100 plus log of x cubed. Log of 100, remember again, if we have no bases, it's really 10. So this is 10 to what power gives you 100? Well, it's 2. And when we have an exponent here, it brings it out in front using the power rule. So we have 3 log x. Well, that better be one of your answers. And we're going to finish off today on 7. We have log base 2 of the square root of 32x to the 7th. We need to remember that log base 2 of the square root of 32x to the 7th can also be written as log base 2 of 32x to the 7th, all raised to the 1/2. And so what we're going to see here is a whole bunch of combinations that we're going to use a bunch of different rules. The 1/2 has to be brought out in front first using the power rule, because that's the 1/2 is attached to everything. So 1/2 log base 2 of 32x to the 7th. Then we see product rule. So it's 1/2 times log base 2 of 32 plus log base 2 of x to the 7th. We then see here that we have 1/2. 2 to what power gives you 32? That's 5. Plus this is another power rule, bring it out in front, 7 log base 2 of x. I'll see you in class.